Hello, today we're going to be looking at loci. The keywords I want you to take note of: number one, angle bisector, path, equidistance, perpendicular bisector, the locus of a point. Okay, now let's look at that. The locus of a point is the path traced out by the point as moves through 2D or 3D space. In loci, problems you have to find the path for a given rule or rules. Now, the locus of a point that moves so that it remains a constant distance from a fixed point P. So let's look at this is what we want to draw, a fixed point P, and you can see the P here. And we want to draw this so that they have the same distance from P. So you find out that the distance is the same thing because this is the radius, so the distance is going to be the same thing. Now, how do we draw this and show our working out? So this is what, let's have a question, and then we'll see how to draw this. So look at this, we now have a circle. Okay, the question is, draw the locus of a point that moves so that it is always 4 centimeters from the fixed point P. Now, what we're going to do, draw the radius of 4 centimeters, draw your straight line, and then from there you use your compass to draw a circle, and that's it. Now the second one, the locus of a point is the path traced out by the point as it moves. So the locus of a point that moves so that it remains equidistant from two fixed points. Now we have fixed point P1 and P2. Now we just want to draw a perpendicular line that breaks, that halves the two of them. So this is what we have, and we want to draw a perpendicular line now. This is what we call perpendicular, when you can have 90 degrees at this point. Okay, so let's go and draw it and show our working out. Now look at this question. Draw the locus of the point that remains equidistant from point A and B. So we have our point A and B. So now you're going to take your compass, join both points with a straight line, A and B. Place compass at A, set over halfway, and draw two arcs. So we stay at point A, we do that cut there at the bottom. So we stay at B and do exactly the same. And then we draw your straight line. So draw the perpendicular bisector to the point of intersection. And that's what we have. Okay. The locus of a point that moves so that it remains equidistant from two fixed lines as shown. So we want to draw this. So this is what we want to draw, or this is how to show our document. Draw the locus of the point that remains equidistant from lines AC and AB. So we do this. We place a compass at A and draw an arc. We draw an arc like that. Then you place your compass on each intersection and set at a fixed distance. Then draw two arcs that intersect. So here, stay on there, C, and cut the arc. Stay on B, on the line on B, and cut the arc. So this is what we have. So this is what we should have. Okay, now the locus of a point is a path traced out by the point as it moves. So we go like this. So the locus of a point that moves so that it remains equidistant from a fixed line AB. So the same distance is what it's having, and that is what we're going to have. So two lines parallel to AB. And that's what we have. Okay, now let's look at some past questions. Mr. and Mrs. Smith went to live within 6 miles. They want to live within 6 miles of the town Ashton and live within 5 miles of Brightfield, shading the region where Mr. and Mrs. Smith can live. And we're going to use a scale. Length of 1 square is 1 mile. So here, all we're going to do, draw your circle, and then we're going to paint. So can you see between here we have 1, 2, 3, 4, 5, 6. So that is 6 miles. And then we do 5 miles there. And we draw a circle. So we have 5 miles. 1, 2, 3, 4, 5. And where the two of them, that's your answer. Okay, we can practice this. Let's do the next one. The new supermarket is going to build. It needs to be closer to Construction City than Protractor's Pond, within 3 miles of Vertisville. Again, we're going to use a scale. Length of 1 square is 1 mile. So here we draw, we bisect the line here, and then we draw the side as well. So we have that. And then we're going to draw 3 miles from here. So we count 3 miles, and that's exactly 3 miles from there. So this is 1, 2, 3. The shaded area. Okay, we go to the next one. Here is a map. The map shows 2 towns, Beaufort and Hightown. A company is going to build a warehouse. The warehouse will be less than 3 miles from Beaufort and less than 5 miles from Hightown. Shade the region on the map where the company can build the warehouse. So here we've seen that it's 3 miles, so we can do that 3 miles, and 3 miles is just 1, 2, 3, and draw the circle. And the next one, we have 1, 2, 3, 4, 5 miles, and where the 2 of them meet, and that's your answer. Okay, let's look at another one. Here is a map. The map shows 3 towns, Ashfield, Bradford, and Cliffview. IKEA are going to build a mega town between the 3 towns. The store needs to be less than 60 miles from Ashfield, less than 40 miles from Bradford, and less than 60 miles from Cliffview. Shade the region on the map where IKEA can build their mega store. So the first thing we're going to do 60 miles from there. We're going to use a scale of length of 1 square is 10 miles. So this will be exactly 1, 2, 3, 4, 5, 6, and that's representing 6. And then here we have 1, 2, 3, 4, 5, 6. 6 miles as well. Then we're going to do that of the Bradford as well. So that represents 1, 2, 3, 4. And where the 3 of them meet, that will be your answer. And that's just the shaded area there. Okay. Now let's look at another one. The map shows the position of 2 schools, Ashford and Bancroft. A new school is going to be built. The new school will be less than 5 kilometers. So less than 5 kilometers. So that is 1, 2, 3, 4, 5. And it will be nearer to Bancroft than to Ashford. Shading the region on the map where the new school will be built. So here we're going to bisect that. Bisect the 2 of them, and that's where the school will be built, just there. Okay, we go to the next one. The diagram shows a garden in the shape of a rectangle. John is going to plant a tree in the garden. The tree must be more than 3 meters from the center of the pond and more than 2 meters away from the patio. So here, what we're going to do, the scale, we're going to use length of 2 squares is 1 meter. Yep, so if we do that, we're going to do this, and then we have less than 1 meter, and this is the shaded area that is left. Okay. Now, here is a scale drawing of a rectangular garden A, B, C, D. Jane wants to plant a tree in the garden, but can't plant it on the patio. It needs to be at least 6 meters away from point C, at least 5 meters away from point B, and closer to B than A. On the diagram, shade the region where Jane can plant the tree. Okay, so here we're going to use a scale. Length of 1 square is 1 meter. And that's what we're going to have. And then this is a place where she can plant the tree. Now let's look at an exam question here as well. Billy the goat is tethered by a 15 meters long chain to a tree. Nanny the goat is tethered to the corner of the shed at B by a 12-meter rope. Draw the boundary. So what's the boundary? Can you see this goat is tied? What is the boundary? How far can he go? So here the first he said, draw the boundary, locus for both goats, and shade the region where the 2 of them. So what's the boundary for A, and what's the boundary for B? And where can the 2 of them meet? So here again, we're going to use a scale of length of 1 square to 3 meters. If we do that, we draw an arc of 5 centimeters, and then we have this. We draw a circle of the radius 4 centimeters as well. And then we have this. Now, this is the region where the 2 of them can meet. The 2 goats can meet in this region. So that will be our answer. So that's about it. Now we're going to practice the questions that are just beneath the screen now.